You did your science for physics also. Shit, and I just told the other student that I'm sorry, Ian. Who's missing from class?做咩面青口順埋你？做咩嚟？咩病？心理上嘅創傷。Guys, 8 minutes, everyone. Faster, Oh yeah, I was just talking to Gilbert about this, guys. We're thinking, right? Since it's after the pandemic, right? How many of you guys will be keen if we like hold an activity to go outside? It could be like something like, I don't know, maybe bowling to surfing or not surfing out the flow rider in one new thing, right? Paragliding probably not, or maybe extreme park in Sunway. Will you guys be keen on that? Are your parents gonna be strict or? Okay, this is the condition. We talked about the payment also. For those who score a certain mark, we will definitely be paying full. So it's going to be like tranches, right? Certain tranches we'll be paying and subsidizing whatever. Yeah, you can call this the scholarship of fun. It's like, yeah. You guys will be keen? I'm actually, or maybe we can organize a paintball event or dodgeball. We're trying to include like everyone, right? I can fit everything. Paintball, do you guys? Do you guys think you guys will be keen? I'm just more concerned for the girls because paintball is going to be hurting a little bit. Or ice skating or rollerblading in one you. Yeah, you guys think you guys will be keen? All right, we'll organize one after your mocks, okay? Organize one after the mocks. So there's a few we're thinking like maybe either bowling or rollerblading or dodgeball, something that can fit like 20 people all together. Which one? Ice skating is the preferred one, is it? Ice skating is the one in Sunway. Escape room is like 1 hour thing only. Won't fit 20 people. It's like maximum 5 people only. Badminton, I don't think all the girls can play also, right? Not everyone plays badminton. Are you screaming? Shut up, lah. What's the difference between rollerblading and skating? One is colder. I personally prefer ice skating as well. But yeah, it's more convenient. Which one you guys want to go to? The Sunway one, or do you guys go to the one in Montclair one? What's that? Okay, I will organize. Okay. Somewhere pyramid. Yeah. That one is big, but there's a lot of people. Sunway Lagoon.
Everyone can play, ma.
Okay. All right. Okay, so Sunway Lagoon, everyone okay or not? Yeah. The girls especially, not the boys. The boys all shut up. The girls, are you guys okay with Sunway Lagoon? Yeah, everyone. Good response. I will assume that's a yes, lah.
Although fail also can go.
Fail, can. No subsidy only, ma.
No sponsorship.
Fail. Okay, everyone. Anyways, please continue doing your work. You have 3 more minutes to complete this, guys. Yeah, I think this was something we wanted to do during the pandemic also. But, yeah, but obviously we couldn't, right? Maybe a outing together with everyone. Yeah.
Yes, sir. Get ready for solid. Yes, anything you want to ask me?
Yeah, it's because DC, if it's DC, right, then you only have that one directional current now. You can imagine, but there's one directional current, cutting the one piece. The only way for this to work is when you have AC, so that the current is always right.
你看你的 method 写什么啊 ？method describing a method， 我写来 describing a method 啊。哎，你下面有写那个答案的，这个是吗？
Which will magnetize
panel 是不是 PANL right？ 啊？知道了 magnet 啊。
有 SIM card 以后的，就是习惯了看到写。对，都冷嘛，3个礼拜有空给你看。
都在。
All right, guys, let's discuss the answers. Nose all the way is empty. Team guy. All right, guys, pay attention. Look here, what's the first question they want from you? A bar magnet is made of metal. Suggest a metal which the bar magnet is made of. Iron, is it? A bar magnet, permanent magnet must be made of iron, is it? It is steel, guys. Why is it steel? Why? Why cannot be iron? Guys, remember this. I think I mentioned this in class. I'll mention it again. Steel is considered a hard metal, guys. It's hard to magnetize, but once you magnetize it, it's very hard to demagnetize. Whereas iron is considered a soft metal, right? Soft metal meaning to say it's very easy to magnetize, but as soon as the current stops, like the one you see at the door, when you click the button, the current stops, you know. That's why I can pull the door open, guys. That is when it straight away demagnetizes. When you're talking about permanent magnets, we always want it to retain its magnetism, right? So that's why steel is the only answer for these kind of questions here. Then after that, is this high enough? It feels lower today. Nickel and cobalt is acceptable as well. Yeah, nickel and cobalt is acceptable as well, but usually we recommend writing steel as the standard answer because for sure it's correct and it's either iron and steel, iron and steel, iron and steel, right? Right. Now after that, the second part here, the coil is connected to a galvanometer. Explain why the galvanometer deflects as the bar magnet is being inserted into the coil. Guys, this one here is essentially talking about Lenz's law, right? Lenz's law states that the induced current always opposes the motion producing it. Guys, how many of you guys don't remember Lenz's law? You need me to give you a quick crash course of Lenz's law here. Right. So basically, for those who forgot what Lenz's law is, Lenz's law states that the induced current will always oppose the motion producing it. For example, today when I'm pushing this thing inwards, right? When I'm pushing this thing inwards, it will actually generate its own north and south. Oi. When it's pushing it inwards here, it will generate its own magnetic field, right? Why will it be north and south here? Because they are always trying to oppose it. But why is there actually a north and south here? It's because there is a current flowing in here, Once you identify this north and south, you can use the right hand grip rule, guys. This thumb is supposed to indicate the direction of your temporary north, and your 4 fingers are supposed to indicate the direction of your current, right? Looking at this scenario here, you see that this is your north and your 4 fingers are pointing upwards, indicating that the current generated here is actually going upwards, guys. And yeah, they'll always oppose the motion. Always remember that. So from here, they're asking you why it deflects. It deflects because of the phenomena known as electromagnetic induction, right? Electromagnetic induction is when your magnetic field is cutting through the wire, or your wire is cutting through the magnetic field to generate current. Electromagnetic induction, guys. So obviously, if you're asked this kind of question, you're supposed to answer accordingly. You're going to say that. You're going to say something like electromagnetic induction occurs. Magnetic induction occurs.
I just say that small EMF will be induced.
Yeah, EMF must be induced before the current. So you're going to say something like, as the magnet is pushed into the solenoid, magnetic field cuts through the coil. Same thing. Inducing EMF in the coil, ultimately inducing current.
So one mark is for the electromagnetic induction.
Let me check. I actually don't know what's the mark scheme, but it'll be always the same thing over and over again. Sorry, my answers. Yeah, magnetic field, cutting magnetic field, EMF induced. These are your 3 keywords. But usually it will be the same thing over and over again, guys. If you look at the mark scheme here, guys, you know, the mark scheme here is always going to be the same thing. When they're talking about all this electromagnetic induction, for sure, you're supposed to mention that the magnetic field is cut, right? For sure, you're going to say that there's a change in magnetic field, and for sure, you must mention EMF. Always remember, guys, EMF must come first before your current. EMF is like a petrol in your car, you know. No EMF, no current flow, guys. Remember that. So that's why you always mention EMF induced, then only current is induced. Oh, for those who are copying halfway. Oh shit. But you don't have to use my words, guys. Like I mentioned over and over again, physics is like, it's like freestyle a bit, right? You can use your own words, but make sure the keywords are there.
I need to say the pushing thing. I can't just say magnetic field is disrupted.
Magnetic field is disrupted. What's your sentence? Show me. Don't say disrupted. The magnetic field is definitely cutting through the coil, not disrupted. Disrupted is like there's 2 magnetic fields interacting with each other already. You know? Oh, for the new student, my words are a bit ugly. You'll have to bear with it. Good. 你想點？你想點？
我想黑㗎。
Hey, done, everyone? Yeah. After that, explain what determines the direction of the reading of the galvanometer. What determines the direction of the reading? Your motion, right? Whether you're pushing it in, it will create a temporary north, or you're pulling it out and it will create a temporary south, guys. When you push it in, like this direction here, it will produce a temporary north and south, right? when you pull it out, it will produce the temporary south and the north here instead, guys. So the motion where the magnet is going in or out is actually going to determine the direction of the current flow.
This one the 2 marks already.
Yeah, I actually don't know why it's 2 marks also. Direction of movement.
Movement of the magnet. I just like.
Yeah. Direction of the movement, then direction of the induced EMF or repel magnet or whatever.
I say the poles of the magnet and the poles of the coil.
Yeah, I think I'll give you an answer here, guys. Write this down. Motion of the magnet determines the direction of current induced. Lens law states that direction. The current induced, sorry, the current induced. Lens law. Yeah, it's very detailed. Usually they won't ask you to in your mark scheme. Usually they don't care whether it's long or short. The keywords there, but I'm writing this so that everyone can understand what's going on. It's like a detailed explanation. But oh, oops, brain jam. What else? Producing that. Yeah. Okay, if let's say, for example, you see here, the north is on the right hand side, right? Means to say the current, you can see the current is coming down like this, right? Then if it's like that, then you can see that the current is actually going upwards. Can you see? Yeah. All right, then final part, describe a method to demagnetize a bar magnet. It's a lot, right? You can either hammer it. There are 3 main methods only, guys. You hammer it in the east-west direction. That's where you get your second mark. You heat it up to high temperatures so the magnetic domains are disorganized. Or number 3, we'll withdraw it slowly from an alternating solenoid while the current is still on. These 3 are super standard questions with super standard answers, guys. But me personally, I like to hammer it because it's the most brutal way, right? Yeah. Yeah, if you hammer it in the east-west direction. Yeah. That is 2 marks. 3 marks. Okay, everyone? Yeah, heating with high temperatures is 1 mark also. Yeah, heat a high temperature, hammer it in the east-west direction, place it in an alternating current, and withdraw it slowly, guys. Yeah, I want to highlight this one as well, everyone. You see the final one here? This is not such a conventional answer. Oi, pay attention. Oi. This one here is not such a conventional answer, guys. Sometimes in your paper, they'll ask you like, how do you demagnetize it using alternating current, guys? If they ask you this, right, you always remember that it's basically you place the magnet in the solenoid, right, with alternating current, and you slowly pull it out from the solenoid. That's always going to be your key marks, guys. You need to slowly remove it from the solenoid. All right. Yeah, must write slowly. And slowly pull it out from the AC before switching off the current. Very standard, this one here also. If they ever ask about AC, this one you're supposed to slowly pull it out, guys. Very important. The keyword here is slowly remove it. Okay. Yeah, do the next question. Ten minutes as well, guys.
Slowly remove the magnet from the alternating current. So keywords is slowly remove. Before you switch off the current, so 一定要把 the current off slowly remove. 这个才是 key。
然后这样 force up。
这个 very good。哦，那样子的这个。So you calculate how much current is flowing here, whether it's flowing or not.
Oh, yeah. Then this one would be right in like.
You're supposed to be calculation also is supposed to prove that whether whatever current is flowing here, will it be more than 3 amperes or not? I should definitely hang this up right. Okay, 投資 see the stock rising already, right? KL 啊，不要很遠。其實我是住 PJ， 我來這邊都很遠。Yeah, I stay right next to St. Joseph, sorry, St. Joseph.
Stay so far that we center here.
That time don't want to compete with the bigger brands. No lah, that's not.
Get the students down there.
Less competition here. When we first started, this is our first center of our own. But now we open up at Damansara town already.
All the two center already.
Yeah. 本来是每一年要一个的 then COVID. Yes. 这一年也就 less than 2 years already. But yeah, we will definitely continue expanding after COVID for sure. You know, Ivan, which one you want to do? So basically, this one there's a current flowing here, right? If there's a current flowing in this magnet, what will happen to it? Will it have something happening to the wire? What will happen to the wire? Yeah. Remember, it's the last week we talked about left hand, right? When to use left hand, when to use right hand. 你先好。Right hand, you remember 中指做人嘅，呢個係 looking for current. Left hand is looking for force 嘛，right? But what's the condition for you to look for force? you must have the magnetic field， 然后这是什么？ current 啊，所以这个是 magnetic field right， 或者是从 north to south 吗？这个是 current 吗？你要找那个 force 吗？所以 use your reference left hand 找看它的 force 在哪里。magnetic field 是 north to south 的，这样子来的。呀，这个 current 跑着进去吗？所以你是 gun hand， 然后这样子的吗？对吗？一定是这里90度，这里90度的吗？对吗？所以现在你看哦，你 north to south， 你不要全部指先，不要 body 一个手指，north to south 先，north to south， 然后呢，你 current coming in right， 所以你看这样子转进来这样子，也就是说你看你的 force 呢？就是说你 force going downwards 啊。Yeah.
Oh yeah, sorry, what?
Huh? Oh, this one right is not related to the question above one. It's like a totally separate question. But I want to confuse them. In fact, I did it wrong also when I first had a look at it. And 我一直不明白，我看着那个 Maxine， 我就讲，我 hell 这 Maxine 错了。And then I realized that they're not related. This is like a totally separate question.
Okay. Alright guys, let's go through the question together, guys. I see most of you guys are done and some of you guys are stuck at certain parts. Guys, looking at this scenario here, look what the question wants from you. Figure 9.1 shows a horizontal wire PQ that is placed in the gap between the north and south pole of the magnet. So there's this PQ wire in between the north and south pole, right? The current, there is a current in the wire in the direction of P to Q. The current is going from P to Q. A force acts on the current in the wire in the magnetic field. First question, do we use the left hand or right hand? Orange. Left or right? Left. Which asshole say right hand? It's supposed to be the left hand, guys. Always remember your right hand is for you to exert dominance, and your left hand is for you to show some sarcasm, right? So in this scenario here, obviously we're given the magnetic field which is going from north to south, and we're given the direction of the current one which goes from P to Q. Using your Fleming's left hand rule, right, you're supposed to determine that. Yet again, always remember, don't go Bollywood dancing in the exam hall. You clench your hand into a fist first. You always point the direction of the north, right? Then after that, you open your finger, you realize that, oh, it's in the opposite direction. You change it here. Obviously, your finger will be down like this, guys. Meaning to say there will be a force acting downwards of this thing here. So you're going to label that F long, right? And the magnetic field is obviously going from north to south, right? So nothing to explain there. Then after that, state the effect of reversing the direction of the current. Today, if it goes from, instead from P to Q, it goes from Q to P. What's going to happen with this wire? Yeah, the force will be upwards instead. There will be a force acting upwards. It will be a force acting upwards, guys. All right. Then after that, question C, the magnet is removed and the horizontal current carrying wire is left on its own as shown. On figure 9.2, sketch the pattern of the magnetic field due to the current in the wire. Guys, which hand rule are we supposed to use for this scenario here? Which is it left? What's this rule called? Right hand grip rule, guys. This here is supposed to determine the direction of the current, and these four fingers are supposed to determine the direction of your magnetic field, right? This one is obviously going into the screen, right? Meaning to say your four fingers are in the clockwise direction, guys. So if you're asked to draw this, you draw as best as you can. I know a lot of you guys, me included, do not have the art genes, right? But you just make sure you draw three. Hey guys, listen up. You don't be funny and try to draw one. In your math team, always, every year, anything that requires drawing, especially all this simple drawing, needs three of it. Pay attention. You need three of it, guys. All right, then you get your marks. Yeah, then it's 3 marks. Crazy, it is crazy. How do you get 3 marks like this? How do you justify 3 marks? It's 3 marks, essentially. Then after that, they ask, they say that the current PQ is increased. Wait, you know, anyone? Oh, by the way, are you guys stuck? Okay, Mo. You sure? Let me tell you guys this. All right, so from here they say that PQ current increase, state the effect of changing this current in the magnetic field. What's going to happen if today my current increase? What's going to happen to my magnetic field? Times 3. It will be greater, right? Because the current is the one that dictates the magnetic field. If today I have more current flowing in, obviously I'll have a stronger magnetic field, and obviously it will be like more lines here, right? But you don't have to draw it. You just say that the strength of magnetic field increases.
Stronger magnetic field.
You have to say denser magnetic field, not stronger, because a stronger magnet just has more magnetic fields. Sorry, what do you want to ask? Denser, guys, the keyword is denser magnetic field lines, because it's not stronger magnetic field. If it has a strong magnet, it will just have more magnetic fields inside. Right. And then finally, a small magnet is placed at a point where the magnetic field is vertically downwards. This question, right? Let me tell you this question, which I had the longest time debating with all my students and saying that the mark scheme was wrong. Yeah. Yeah, you know what's happening, right? Initially, when I read this question, it says that a small magnet is placed at a point where the magnetic field is vertically downwards, state the direction of the force on the S pole. So I'm thinking like, initially I'm thinking that there is a magnet here, right, that has a magnetic field like this downwards. And if you follow the roundabout rule and the guitar string theory, right, it's supposed to actually generate a force towards the left, right? This was what I initially thought for this question, but it turns out that it is totally a wrong misconception, because first and foremost, this question has nothing to do with this question, right? They're just asking that if I have a magnetic field that is vertically upwards, then they're asking me what happens to the S pole. If I have magnetic field vertically upwards, the north will be here and the south will be here, right? Right. Meaning to say the force on the S pole is going downwards. You get what I mean? So it's actually a very dumb question.
Yeah, I thought it's one bar magnetic.
Yeah, exactly what I was thinking also, but I was wrong and dumb. All right, but now you know it's a dumb question, guys. It's just stating that there's magnetic field going upwards. They're asking what happens to this S pole here only, guys, which obviously is being attracted downwards. Being attracted downwards. And these are the things you're supposed to know for this structure here. Okay, guys, anyone's got any questions with this part here? Anyone don't understand whatever I've mentioned so far? Excellent, 100% absorption rate. Do the next one. The next one is the 2018 paper, guys. 下面那边有写一个2018的。Guys, same drill as well. I'll finish the ABC question first, guys. You have 7 minutes. Hey, if you guys are stuck, please make sure you voice out. I can guarantee you staring at the question will not help.
That's right. Current is N to S, right?
Current is N to S.
So the magnetic field, sorry.
Yeah, magnetic field is always north to south.
Yeah. 这都这样子吧，这个进去嘛，然后开始这样，进去，only 6 students，然后还有10 students。这个，哎呦。 为什么可以说研究的时候我方面看到？哦，这个，not， 对，来，这是这样子，这样看啊，这样子啊，这样子。
Yes. Yeah. And so one is going to the battery, which is one of the battery. You have a set of so it's correct. The long distance equals 0.5 seconds. The direction of magnetic field is parallel. The direction of the magnetic field is perpendicular. Like this direction. 这个 control 这个是 3D 吗 ？Right， 这是 2D 的，这是 1D 的 pitch 还是 clockwise 呢 ？It's going to be clockwise. Which one is the one that follows? You know what's the concept here? This concept is that the stronger magnetic field is equal. What do you think after this? That's wrong. This is actually that. Oh.
Is the answer donkey?
No. Yeah. Why?
Because people can just see it. 这边的资料，这个一定是这边一定是三个嘛。
This is not what it's all for. That's not It is not an install. Then all you need to read is you have to magnetic field. Yeah. It's parallel.
Oh. Oh, yeah.
You get it?
对呀，60块出。
多少钱啊？
我没有吃这种东西。
几钱？我出啊，今天。
哇！
没有，你的下个星期60块太少了。
还是你要多一个，要大一点的。
我要
这个
2
recipe 的。
这个才不能做。
没事，还
appetizer 上个礼拜就开始吃到哦，可是突然之间不够了。Okay, guys, I think you had enough time to attempt it. Let's go through the questions together. All right, listen up, guys. Question number 1 here: the current in the coil produces a magnetic field around it as shown. Right. The magnitude and the potential difference across the coil is increased and the direction is reversed. So they're basically saying that the current reverses, guys. So initially, if here is north and here is south, when you reverse the current, where will the north be, Brian? Reversal, right? It will be north and south here. So that's your idea in your head already, right? What happens to the magnetic field? Because your current increases, obviously the line is going to become closer together, right? Because it's more densely packed already, the magnetic field, right? Then after that, and the right hand becomes the south. Oh, sorry, the right end becomes the south pole. Yeah. Right hand becomes the south pole. Right. Because initially here is north and here is south. You can see from the arrows here, guys, the magnetic field will always travel from north to south, guys. Right. Then reverse it, everything reverses. Then the next part, the diagram shows a current carrying conductor in the magnetic field. Which row shows the direction of the force acting on the conductor? Which hand do you use for this one? Left or right? Left, good. Left is always looking for force, right? So in this scenario here, your magnetic field is going in that direction, right? Your current is going to go inwards because the current is traveling here, right? The current is traveling here, right? So it's going inwards, and your force obviously is going to be up, guys. You're supposed to have this hand here, right? Answer is supposed to be A. Anyone got this wrong, by the way? I want to know so that I can beat you. For you again. Next one, for sure, ask you. Question 3. In the AC generator, a coil is rotated in the magnetic field and alternating, and an electromotive force is induced in the coil. In which position of the coil does the EMF has the largest value? Guys, what's the condition for you to generate the largest EMF again?
With the magnetic field.
What's the term called? Parallel or perpendicular?
Parallel.
Parallel, is it? It's supposed to be perpendicular. Hello, listen up. Look at these two scenarios here. It's either between A or C, right? At this instance here, everyone pay attention to this. You will be asked this in your paper 4. You see the magnetic field right now is like this, right? It's like this, right? At this instance for A, is moving like this, right? Do you think this will generate more current, or do you think that this magnetic field, which is like this, and this coil is moving at this, like this instance here, which one will generate more current? Ian? Definitely A, guys. The condition for you to generate the maximum current or voltage or whatever must be that the coil is cutting through perpendicularly against your magnetic field. And in your paper 4, they ask you how. You're going to say that it must be cut perpendicularly because it cuts through the most magnetic field lines at this instance, guys. Keyword perpendicularly and cuts through the most magnetic field line at this instance. Obviously, answer is A. All right, then question 4. Wire P carries a current directly perpendicular into the page. It's going into the page. A compass is placed at Q. This is a compass which is close to wire P. The magnetic field at Q, due to the current, is much larger than the magnetic field due to the Earth. So they're saying that this magnetic field generator is much larger than this magnetic field, right? In which direction does north pole of the compass point? Guys, this scenario here is the exact scenario where a stronger magnet is going to influence a weaker magnet. They already stated here that P's magnetic field line is stronger than Q, meaning to say Q is the gan mei gao, you know, it has to follow P, guys. If it has to follow P first and foremost, you're supposed to determine the direction of the magnetic field for P. How do we determine the direction of the magnetic field again? Yeah. Exactly. Your thumb is pointing into the screen, and your 4 fingers are going to be in the clockwise direction. So you're pointing inwards and your 4 fingers are supposed to be in the clockwise direction. If you understand that the magnetic field here will be in the clockwise direction, A, B, C, or D? Definitely A, guys. Okay, so basically, let's imagine that the magnetic field is a bit larger, right? The magnetic field is like this. Right, can you see this? The magnetic field, which is this stronger magnetic field, which is from P, will influence the weaker magnetic field, which is from Q. You get what I mean? It's the same thing like if today you put a compass in the north and south here, right? Your compass for sure will point this way on, right? Because the magnetic field from the permanent magnet is going downwards. So your compass will follow the direction of the magnetic field. But no. All right, then obviously this question here is going to be C lah. I don't know any other answer. What do you write?
Okay, man.
The axis along the is 0. Okay, let me tell you why that is so ridiculous. Do you see here?
Oh, sorry,
Do you see this?
I thought you're still talking about this question.
Oh, question 5 lah. You see this? These are all magnetic field, right? This diagram here shows that the magnetic field does not end at the north and south only. It will continue inside the magnet as well, guys. You understand or not? From here, obviously, looking at all these answers here, the direction of the magnetic field is parallel to the axis, because if let's say here is north and here is south, right? The magnetic field will be going in like this and like this, right? It will go inwards. I always remember the magnetic field doesn't stop at north and south. It will continuously go all the way inwards throughout the whole magnet. Right? Yeah. 你係咪喺屋企俾人打得少？俾我講，你呢個相都係俾我打係咪？ It is lah. Yes. Okay, one last question, guys. I'll pick one question for you guys to do. Look at here. This question. Everyone pay attention to this. This is one of the questions that I can't remember which year. This was 2018, right? I remember one of my students coming back and telling me she had no idea what this question was asking. Everyone read this question. I'll give you 2 minutes before I discuss the answers. Do this one right now. Speed, strength, and number of turns. What do you miss? The magnetic field. What? Diameter of the ball. What number of turns of the ball? I would say 9. I wouldn't write that. I would write number of turns. It's a more standardized answer. And the speed of the coil which is starting to move.
Don't say something like this. If I move faster,
you cut the magnetic field faster, the speed of the coil. But I'm asking you to do 9A. Sorry.
老师讲做第9题我写下来了。Then the answer you tell me. Number of turns.
Number of turns in the coil, strength of the magnet, and the speed of the coil. That one is in the notes. I can write it down yourself later on. Everyone take this question first.
这个是回来的 strength of magnet.
Strength of the magnetic field. Strength of the magnet is acceptable as well.
Strength.
Oh my god, 讲不清楚的。看你的 notes， 看你的 notes from last week.
这个上面 talk you.
Oh, sorry. Who's talking to me? Sir, I 交信
Go eat dinner.
哇
OK，他已经走了。
All right, guys. Can anyone tell me what's wrong with this question or not? What? Yes, that's a key word here, guys.
Shit,
Tristan.
bro.
所以说我 practice 了，我在找人接班了 physics. Look here, look at this question here, guys. This is essentially what you're supposed to do to demagnetize it using an alternating current. If you look here at the question, it says that a student wants to demagnetize a permanent bar magnet. She suggests these few steps. Place the magnet in the long coil, which is essentially the solenoid, guys. Switch on the large alternating current. Must use the alternating current. Then here, this is the problem. Is switch off the current, then only remove the bar magnet from the coil. By right, you're supposed to remove the bar magnet from the coil slowly, then only you switch off the current, guys. So if you swap this over and you write slowly, then you'll be everything correct already. Oh, explain why. Oh yeah, actually I forgot about this. Explain why. Because actually, how am I going to explain this? Let me have a look. Just would not be effective for me. With current on, should not be switched off. Yeah. For the explain part, guys, just write it would not be effective and it will retain its magnetism when you switch it off. So state and explain the steps will always be able to demagnetize the magnet. No.
So wait.
Shit. Answer is no. Why? So,
几点吃哦？来了。
8:30才能回来。
醒8点嘛？是不是9点？那个哇，
然后就只可以回家。
是啊。哦。
你就不用开嘛，你直接你做完就可以讲完什么。
1 hour near. Wait, 1 hour near什么
Yes. 有啊，我也还有教。
不要玩。那你叫第二天哦，他 English 和 Math 考虑。
是。一完球。哎，我们拉斯亚一个。
Something along the lines.
我等我那家长我再去过来干嘛？
不要不到。
Okay. No one. What's that? Bang. Don't know. Yeah, you could say so. I don't have any other jobs besides having fun outside. Okay, guys. Hey, I want you guys to finish off everything else from this exercise as your homework, guys. Everyone pay attention, especially those who are here because you are physically here. When next week you don't do my homework, I will beat you one by one, guys. Until you finish the May June 2018 paper, which is this page here. Not a lot only, just do, you need to exercise anyway, right? You go to exam, you don't know how to do this, is that going to be good? No. That's going to be shit also, right? Shit. All right, so hey, homework until this page, everyone. Okay? All right, that will be it for today, everyone. Anyone got questions, you are more than welcome to stay back. If not, enjoy the rest of your night. Yeah, where is he?
Yay!
No, small
More business.